Welcome to Tomorrow Unveiled. It is Thursday, January 22, 2026. I want to start today by asking you to do something very simple. I want you to take a second and just look at your wrist right now. Maybe you're wearing a smartwatch. Maybe you've got a ring on your finger that's, silently tracking your sleep stages. Now, I want you to imagine a world where those devices aren't just accessories anymore. Imagine they aren't even devices in the way we think of them today. These chunks of metal and glass you have to remember to plug in every night, or they turn into expensive paperweights. We are standing on the precipice of a really radical shift. The definition of wearable is completely dissolving. We aren't just talking about step counters or heart rate monitors anymore. We are talking about technology that is literally dissolving into the background of our biological lives.
It really is. It's a fundamental change in the architecture of how we live. If you look back, we've spent the last decade or so in the era of gadgets. Things you strap on, things that beep at you, things that demand your attention. But looking at the research team's findings from just this past week, the theme that just screams out is the invisible revolution. We're moving from clunky hardware to seamless partners. We are seeing tech that predicts health crises weeks before you feel a single symptom, robotic enhancements that augment your physical strength without you even thinking about it, and interfaces that wire directly into the human brain to update your mind just like you update your phone.
And that is exactly what we are unpacking for everyone listening to Tomorrow Unveiled. We have a massive roadmap ahead of us, focusing on three main pillars that our research team has dug up from the last 7 days of news and technical leaks. First, we have the ultimate interface. We were looking at a massive update on Neuralink. And I'm not talking about experimental lab rats. We are talking about a shift to high-volume production slated for this year, 2026, and a stunning revelation that brain chips can now be fixed with software updates exactly like your car.
That analogy, the Tesla of the brain, is so incredibly apt, and we're going to get into why that changes the medical landscape entirely. Then we need to talk about the pivot to vision. There has been a lot of noise about Apple moving away from those heavy immersive headsets. The research team has pulled details on Project Atlas, the secret shift what insiders are calling AirPods with eyes.
And finally, we are going to get a little sci-fi, but it is very, very real. We are looking at supernumerary robotic limbs, or ERAs. These are wearable robotic arms that allow a single person to do a two-person job. It sounds wild, but the data is incredibly compelling.
So the mission for this episode of Tomorrow Unveiled is pretty clear. We want to understand how we're moving from, strapping technology on to actually weaving technology in.
Yeah.
It's no longer about tracking what you did yesterday. It's about predicting what you need right now and, in some cases, physically helping you do it.
Okay, let's unpack this. Let's start with a heavy hitter, Neuralink. If you've been following the headlines, you know Elon Musk made a major announcement right at the start of the year. Neuralink is shifting gears to high-volume production in 2026. Now, usually when I hear high volume, I think of coaster ovens or iPhones, but we're talking about brain surgery here. How do you make brain surgery high volume?
That is the critical question, isn't it? For years, brain-computer interfaces, or BCIs, have been treated as science projects. They were experimental, bespoke, extremely rare. You'd have a team of 10 neurosurgeons hovering over one patient for 12 hours. When you hear high-volume production, that signals a move to a standardized medical product. It means the manufacturing processes are being locked in. But what's even more fascinating here is the detail our research team flagged regarding the surgery itself. Specifically, a breakthrough regarding the dura.
Right, the dura. For those who maybe skipped biology class, that is the tough membrane covering the brain, essentially the final line of defense protecting your gray matter from the world.
Exactly. And it is tough for a reason. Historically, implanting electrodes often required removing or significantly manipulating that protective layer. You basically had to cut a window in the dura to get the wires in. That increases surgical risk, it increases the chance of infection, and it drastically increases recovery time. You can't just send someone home an hour after you've cut open their dura.
So what changed? What's the breakthrough?
Well, the new production lines and surgical protocols involve these highly automated systems, specifically the surgical robot. The device's threads can now go through the dura without needing to remove it. Think of it like a sewing machine that's so precise it can thread a needle through a piece of fabric without tearing the weave.
That sounds like a technicality, but I'm guessing that's a game changer for the patient experience.
It is a massive deal. It drastically reduces the complexity of the surgery and the trauma to the body. If you want to reach high volume, You cannot have a surgery that takes all day and requires weeks of intensive care recovery. You need a streamlined, almost entirely automated surgical procedure, which is exactly what the sources are describing for the 2026 roadmap. It turns a major operation into something that looks a lot more like outpatient laser eye surgery.
And speaking of the patient experience, here's where it gets really interesting. We have to talk about Nolan Arbaugh. He was the first participant in the Neuralink trials. His story is basically the proof of concept for this entire software-defined human idea. But it didn't start smoothly, did it?
No, it didn't. And this is a story that I think got buried a bit in the general hype, but the details are absolutely crucial. Nolan's case is fascinating because it exposed a hardware failure that turned into a software triumph. After his surgery back in 2024, everything seemed fine. But then there was a significant issue. About 85% of the electrode threads that were implanted actually detached from his brain.
85%? That sounds catastrophic. I mean, imagine buying a new car and 85% of the engine components just fall out a month later.
In a traditional medical implant context, that is a catastrophic failure. If 85% of the leads on a pacemaker detach, the patient is in immediate danger, and you are back on the operating table immediately. You have to go in, cut them open, remove the device, and start over. It is an absolute nightmare scenario.
But that didn't happen here. Nolan didn't go back for more surgery.
No. And this is the mind-blowing part. Instead of cutting him open again, the team performed an over-the-air update, an OTA update.
It's like downloading the latest iOS or updating your Tesla firmware while it sits in the driveway. But I don't get it.
Yeah.
How does a software update fix a wire that is physically not connected anymore? You can't code a wire back into place.
That is the brilliance of it. Think about it like a cocktail party. Originally, Neuralink had a microphone at every single table. Those are the electrodes. They were getting crystal clear audio from each conversation at each table.
Okay, I'm with you so far.
But then the threads retracted. It's like 85% of those microphones were pulled away from the tables and are now hanging from the ceiling. Suddenly, the audio is faint, it's muddy, you can barely hear the conversation. In traditional medicine, you'd say, the sensor is broken, we need to go back in and place it closer.
Which means another brain surgery.
Exactly. But the Neuralink engineers realized the signal was still there. It was just buried in all this noise, so they didn't touch the hardware. They rewrote the recording algorithm to be hypersensitive. They basically turned up the gain on the remaining microphones and used AI to filter out the background noise of the room. They modified how the signals were processed to extract more data from fewer connection points. Nolan Arbaugh himself compared it to a Tesla update. It's a software fix for a hardware problem.
So what does this all mean for the future? It implies that once the chip is in, the capabilities aren't frozen in time. They can evolve.
That is the profound insight here. It creates what the sources call a code for immortality regarding the system's utility. Your brain chip can be infinitely iterated. You could wake up one morning with better signal processing, faster typing speeds, or new control features, all because an update was pushed from the cloud while you slept. It fundamentally changes how we view medical implants. They aren't static prosthetics anymore, they are evolving platforms.
And the research team mentioned this telepathy app, which is the user interface for these chips, constantly getting updates from the cloud. It really does blur the line between a medical device and a piece of consumer electronics. But looking ahead, Musk is already talking about dual brain interface systems. What's that about?
Yes, the possibility of implanting a second chip. If one chip gives you a certain bandwidth of communication with a computer, two chips could theoretically double that. It suggests a future where we aren't just restoring function to those who are paralyzed, which is the primary crucial goal right now, but eventually enhancing capabilities. It really raises an important question about where therapy ends and, well, where augmentation begins.
Which is the perfect segue to our next topic.
Yeah.
Because if Neuralink is about augmenting the mind from the inside, Apple is apparently figuring out how to augment our reality from the outside, but without making us look like cyborgs.
This is the pivot to vision.
Right. And we have to talk about the context here. We've all seen the Vision Pro. It's impressive, it's powerful, but let's be honest. It's a helmet. It's heavy. It's expensive.
And according to the latest leaks our research team dug up, Apple is making a hard turn. They are deprioritizing the lighter version of that headset to fast-track a project codenamed Project Atlas.
The industry calls this the shift from spatial computing to visual intelligence. Spatial computing, those full headsets, is incredible for immersion. But it turns out people don't want to walk around a grocery store wearing a helmet. It isolates you. The industry is realizing that while headsets are for enthusiasts and specific workflows, smart glasses are for everyone.
So let's describe what this Project Atlas or the N50 prototype actually looks like. The forces describe it as AirPods with eyes.
Yeah.
That's a sticky phrase, but what does it really mean?
It is surprisingly accurate. The leaks suggest the first generation won't even have a holographic display. No little glowing screens floating in front of your eyes. It looks like a pair of high-end designer frames weighing under 50 grams.
Wait, hold on a second. If there is no screen, what is the point? If I buy smart glasses, I kind of expect to see my text messages floating in the air.
That is the old way of thinking about it. The point isn't to display content. The point is the sensors and the intelligence. It's packed with high-fidelity cameras, microphones, and sensors. And crucially, it uses directional audio. It beams sound directly into your ear canal so no one else hears it.
Okay, so walk me through the user experience then. If I can't see a screen, how do I actually use it?
It changes the entire interaction model from touch and see to look and ask. The glasses act as a third eye. The AI, specifically the revamped Siri that our research team says is anticipated in spring 2026, sees what you see.
Okay, let's play this out. I'm walking down the street in Tokyo. I don't speak a word of Japanese. I stop at a restaurant.
You look at the menu outside, you don't take a picture, you don't pull out your phone, you just tap the frame of your glasses and ask, what is the spicy dish on the second line, and does it have peanuts?
And the glasses. They just see the text.
The cameras see the text, the AI translates it instantly, analyzes the ingredients based on its database, and whispers the answer right into your ear. That is the spicy tuna roll. Yes, it contains crushed peanuts.
That is seamless. It's completely context-aware. It feels less like using a computer and more like having a superpower.
Exactly. Or imagine you're at a conference. You see someone whose face looks familiar, but you just can't place them. The glasses recognize the face and whisper, "That's Sarah. You met her at the tech summit last year. She works in clean energy."
That would save me a lot of social awkwardness. But I have to stop you there because my alarm bells are ringing. Privacy. If I have cameras on my face analyzing everything, isn't that a nightmare? I mean, we all remember the glass hole era of Google Glass where people were getting kicked out of bars for wearing them.
That is the elephant in the room, and it's a huge hurdle. But the no display aspect actually helps here, believe it or not, because the notifications are audio-based, they are personal. It's not a screen loading up that everyone around you can see, it's a whisper in your ear.
Sure, nobody sees my notifications, but everyone sees me wearing cameras. If I'm looking at you with these glasses, you have to assume I'm recording you, right? How does that not make things incredibly weird?
And that's where the distinction between recording and machine vision comes in. The sources mention that the industry is trying very hard to distinguish these use cases. The cameras are machine vision sensors. They're looking at the world to answer your questions, not necessarily to store footage on a hard drive for later. But does the average person on the street know that difference? Probably not. It creates a massive social tension.
It seems like the goal is to keep you in the real world, not pull you out of it. But the social contract for that technology hasn't quite caught up yet.
Precisely. The Vision Pro blocks the world to show you a digital one. These glasses let you see the real world, just with an added layer of whispered intelligence. It's much more compatible with actual daily life, but we are definitely going to have to navigate the surveillance aspect very, very carefully.
We're going to dive into how these wearables are revolutionizing our health and physically changing how we work, literally giving us extra limbs in just a moment. But first, we want to make sure you don't miss a beat of what's coming next on Tomorrow Unveiled. If you're finding this insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and consider hitting that new hype button to help us reach more viewers. And of course, be sure to turn on notifications so you never miss an update on the future.
And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It truly helps us reach new listeners.
Welcome back to Tomorrow Unveiled. We've talked about the brain and we've talked about the eyes. Now let's talk about the body, specifically the invisible health revolution. It feels like 2026 is the year the smartwatch finally got some serious competition.
The form factor is absolutely shifting. The trend we are seeing in the 2026 data is that smart rings are moving from a niche product to the mainstream. In some demographics, they're actually threatening to outshine smartwatches.
I totally get it. I mean, sleeping with a bulky watch on isn't great. It gets caught on the sheets, the screen flashes in the middle of the night, a ring just disappears.
That's the appeal. It's all about discrete sensing. Companies like Aura, which our research team notes is now valued at an incredible $11 billion, Ultrahuman, and Rincon with their Gen 3 are proving that people want the data, but they don't necessarily want another screen demanding their attention. They want the tech to be invisible.
And it's not just about counting steps anymore. The sources highlight this partnership between Aura and Quest Diagnostics. That feels like a significant bridge between the wellness world and actual medicine.
It is a massive bridge. It connects the wearable data directly to clinical data. You can schedule lab tests directly from the app. But the real magic is in the interpretation. It's not enough to say you slept bad. The new generation of AI in these devices is starting to explain why.
Give me an example of that. How does a Ring know why I slept badly? It doesn't know what I was doing.
Well, it knows more than you think. The AI might notice your heart rate variability is low and your sleep was fragmented. But it can also have access to your calendar and your location data if you let it. So it sees you had a late meeting at a high-stress location, like your office. It concludes, your poor sleep was likely caused by elevated cortisol from that late meeting. Then it might suggest a specific wind-down protocol for next time. It's moving from just monitoring to active coaching. It connects the dots that you might miss yourself.
That is genuinely useful.
Yeah.
But the hardware is getting even more diverse than just rings. I saw mention in the research of something called the pedal.
Yes, the pedal. This is a health tracker designed to sit inside a bra. It measures heart rate variability, breathing, and it can even assess breast tissue health over time. Again, it's invisible. It integrates into clothing you are already wearing. It's taking advantage of real estate on the body that is consistent and really close to the heart.
And on the more directly medical side, there's the CF patch. This sounded incredibly important for people dealing with chronic conditions.
This is a fantastic application of wearable tech. It's a microfluidic sweat sensor for cystic fibrosis patients.
Okay, microfluidic sweat sensor. Let's break that down for everyone.
Sure. So cystic fibrosis management usually requires frequent trips to the clinic for something called a chlorodometry test. Basically, they need to measure the amount of chloride in your sweat to see how the disease is progressing or how well certain drugs are working. Usually that means a hospital visit. This patch collects sweat on the skin, channels it through tiny microscopic tubes, that's the microfluidic part, and analyzes the chemical composition right there on your arm.
So it does the lab work on your arm, in your home.
Exactly. It allows doctors to monitor chloride levels in real time without the patient ever leaving their house. That saves time, stress, and a ton of hospital resources.
And speaking of saving hospital resources, there was a statistic in the research about heart failure prediction that just blew my mind.
This is where predictive health becomes a reality. The research shows that wearables like the Vital Patch can predict heart failure hospitalizations up to 32 days in advance.
A full month in advance. How is that even possible? Usually you don't know you're in trouble until you literally can't breathe.
Well, the body gives off subtle signals long before you feel the major symptoms. The patch is constantly monitoring subtle changes in your fluid status, basically how much water you are retaining in your chest, and it tracks your heart rate trends over rinse. It catches that slow decline long before the patient feels catastrophic symptoms. And the data shows this can reduce 30-day readmission rates by 89%.
89%. That is a staggering number. It saves lives, and it saves the healthcare system billions. It really emphasizes the shift from reactive medicine, waiting until you have a heart attack, to proactive medicine. Okay, now let's pivot from saving the body to augmenting it. This is the part of our look at the latest in wearables where I feel like we stepped into a comic book.
The supernumerary robotic limbs.
ERAs, wearable, extra robotic arms. Our research team pulled a fascinating paper on this, and to be clear, we aren't talking about a prosthetic for someone who lost an arm. We were talking about giving a healthy person 4 arms.
Exactly. The concept is literally having 4 arms. And the tech is surprisingly lightweight. The prototype described in the research weighs only 2.8 kilograms. That includes the vest, the battery, the controllers, and both robotic arms.
That's lighter than a heavy winter coat. But I want to get to the how here. I'm wearing this vest. I have 2 robot arms sticking out from my sides. I don't have a joystick. I'm not using voice commands. How do I tell the robot arm to grab a drill?
This is where it gets really sci-fi. It uses a sensor glove on one of your real hands. The system uses a lightweight neural network to create a shadow of your own movement.
A shadow? What do you mean?
Imagine making a shadow puppet on the wall. Your hand moves, the shadow moves with it. The ERA, the extra robotic arm, is the shadow. If you reach your real hand forward, the robot arm extends forward. It mimics you almost perfectly. It creates this neural network mapping between your biology and the machine.
Okay, but if it just mimics me, isn't that kind of useless? I mean, if my hand is already full, I can't move it to make the robot move. If I'm holding a cup and I want the robot to also hold a cup, I can't just drop my own cup to move the robot arm.
But that's where the holding mode comes in. This is the genius part. The sources describe a 4-cup scenario. Imagine you need to move 4 full cups of water across a room.
Okay, usually I'd grab 2, move them, come back, grab the other 2, a 2-trip job.
Right. With the ERA, you reach out with your empty biological hands. The robotic arms mimic you, and their soft grippers grab the first 2 cups. Then you flex your little finger.
Just a pinky flick. That's it.
That's the trigger. That little muscle flex signals holding mode. The robot arms lock in that position. They decouple from your hands movement. So now, the robot is holding the first 2 cups steady, and your real hands are completely free again. You grab the next 2 cups, and now you are carrying 4 cups at once.
That is incredible. I can immediately see so many uses for that in construction or surgery or even just around the house.
The research paper lists several. Holding a drawing board steady while you draw on it with your real hands, clamping a piece of wood in place while you use a drill, opening a door while your hands are full of groceries.
It's like having a helpful friend standing behind you, except the friend's attached to you and it's controlled by your own muscle twitches.
It connects to the future of work. We talk so much about automation replacing workers, but this is cooperative manipulation. It allows a single person to perform tasks that used to require 2 people. It makes the individual worker more capable and more independent.
And speaking of capability and independence, we have one final piece of tech to cover. It brings us right back to that fascinating idea of translating senses.
This is the Ally wristband by Hapware. It's a brilliant example of accessibility tech. It pairs with smart glasses, just like the ones we were discussing earlier from Project Atlas.
So the glasses see the world, but the wristband is doing something else entirely.
It uses haptics vibrations to decode facial expressions for the wearer. Think about blind or neurodivergent users who might struggle to read social cues. The glasses see that the person you are talking to is smiling or frowning or looks confused.
And then the wristband vibrates in a specific pattern to tell you that, like a kind of emotional Morse code on your skin.
Exactly. It translates visual social data into tactile data. It is a fundamental rewiring of how we interact with the world. We are seeing wearables that turn vision into touch, that turn muscle signals into robotic movement, and that turn biological data into medical predictions.
So let's zoom out. We've gone from brains that update like Tesla's, to glasses that whisper to us, to rings that book doctor's appointments for us, and now vests that give us extra limbs. What is the through line here? What connects all these things?
I think the theme is ambient intelligence. The technology itself is disappearing physically. It's becoming threads in the brain, rings on fingers, glasses on faces. But its impact is becoming omnipresent. It's becoming a layer of understanding between us and the world. It's no longer a tool you pick up and use. It's a filter you live through.
It really feels like we're not just wearing technology anymore. We're upgrading the human operating system.
We are, and that raises a final provocative thought for everyone listening to Tomorrow Unveiled to mull over. As these devices move from monitoring us to predicting for us and even moving for us, at what point does the wearable stop being an accessory and start being a part of the self?
That's a heavy question.
Well, think about the Neuralink example. If your brain chip updates overnight to process information differently, are you the same person in the morning? If your robotic arms hold things automatically based on your intent, is that you holding it or is it the machine? The boundary of the self is getting very, very blurry.
That is something I'm definitely going to be thinking about for a long time. We love hearing your thoughts on this. Whether you're on YouTube or your favorite podcast app, leave a comment and let us know what you think about Human 2.0 and the rise of robotic limbs. Would you wear a vest that gives you extra arms? Let us know.
It's a conversation we all need to be part of as this technology arrives.
Absolutely. Thanks for joining us on Tomorrow Unveiled. We'll see you in the future.